All right, let's jump right in. Today, we are going to tackle a word that, let's be honest, makes a lot of people a little nervous, the logarithm. But I'm going to promise you, by the end of this, you'll see it's not some scary monster from math class. Nope, it's actually a super intuitive and really powerful way to make sense of a world where things exist on wildly different scales. So, just to show you what I mean, let's try to make a simple chart comparing the planets and the sun. Right away, you can see the problem. The sun is just so enormous that its bar flies right off the screen, and meanwhile, all the planets, even a giant like Jupiter, are just squashed down here into these little tiny specks you can't even read. I mean, can you tell if Saturn's bigger than Neptune? No way. The comparison is totally useless. And that really gets to the heart of it. That's the big question, right? How do you compare things when their sizes are just astronomically different? And this isn't just about planets. This is a challenge we face with everything from economic growth to the data on your computer. Well, the answer, it's kinda to shift our perspective. We need to stop looking at the numbers themselves and start thinking about their scale. And the perfect mathematical tool for doing exactly that is the logarithm. Okay, so let's just break this down. Let's forget all the complicated formulas for a minute. At its absolute core, a logarithm just answers one simple question. How many times do I need to multiply a number by itself to get some other number? That's it. For instance, how many 2's do we multiply together to get 8? Well, let's see. 2 times 2 is 4, times 2 again is 8. That's 3 2's. So the logarithm is 3. Seriously, that's the main idea right there. And this should sound kind of familiar, right? Because it's just the other side of something we all learned about, exponents. Saying 2 to the power of 3 equals 8 is just the exponential way of looking at it. The logarithm just flips the question around and solves for the power. They're just two sides of the exact same coin. So here it is, the key phrase. The logarithm is the exponent. So the big takeaway here is that a logarithm isn't just some random calculation. It represents the scale of a number. It's a way of counting its orders of magnitude. You know, it's kind of like counting the number of digits in a number. 1-digit numbers, 2-digit numbers, 3-digit. Each of those is a totally different scale. That's exactly what a logarithm is measuring. Now, you'll run into a few different flavors of logs, and it all just comes down to the base number they use. Base 10 is the common log, and it's super intuitive for us because, we count in tens. Then you have base E, the natural log. Sounds a bit weird, I know, but it is absolutely essential for things in nature that grow continuously. And finally, there's base 2, the binary log, which is the absolute bedrock of computer science. It's all about how many times you have to double something. Okay, so we know they're useful now, but what's really fascinating is that long before they were powering our computers, logarithms were basically the original life hack for scientists and astronomers, and they solved a problem that had been driving them crazy for centuries. So you gotta picture this. It's before the 1600s, and if you're an astronomer, you were spending your entire life, literally, doing these insanely huge multiplication problems by hand. It was tedious, it was slow, and it was so easy to make a mistake. And then, bam. In 1614, this guy, John Napier, publishes his first logarithm tables, and it was like he discovered actual magic. He found a way to turn a nightmare multiplication problem into a simple addition problem. Soon after, Henry Briggs made them even easier with base 10, and the slide rule, which is basically a physical calculator powered by logs, became the essential tool for every scientist and engineer for the next 300 years. And look, I am not exaggerating the impact here. About a century ago, the mathematician E.W. Hobson called their invention one of the very greatest scientific discoveries that the world has seen. I mean, think about that. Logarithms didn't just help science. They literally put scientific progress into hyperdrive. All right, so that's the history lesson. Super important stuff. But what about today? Well, it turns out logs are arguably even more important now. They're kind of hiding in plain sight, hardwired into pretty much everything in our modern world. In computer science, for example, logarithms are the secret sauce that makes everything so fast. Imagine you're looking for a name in a massive old-school phone book. You're not going to start at page 1 and read every name, right? Of course not. You'd flip it open right to the middle, then you just ask, is the name I want before this page or after it? And just like that, in one single step, you've thrown out half the book. You just do that again and again, having the problem each time until you find it. That whole divide and conquer idea, that's the power of the logarithm in action. It's why you'll hear computer scientists get all excited about something called O log n complexity. Now, that sounds fancy, but all it really means is that even if your list, that's the n, gets ridiculously huge, the time it takes to find something barely goes up. It's the magic that lets a search engine sift through billions of web pages in the blink of an eye. And this way of thinking, it goes way beyond just code. In economics, for instance, logarithms are the natural language for talking about growth. They're used for everything from modeling GDP to calculating compound interest. And you know that feeling where the first slice of pizza is pure heaven, but the second one is just pretty good? That's a real concept called diminishing marginal utility. And yep, it's described perfectly by logarithms. In fact, what's really wild is that you use logarithmic scales all the time, probably without even thinking about it. When an earthquake is a 6 on the Richter scale, it isn't just 1 point stronger than a 5. It's 10 times more powerful. The decibel scale for sound, the pH scale for acidity, even musical octaves, they are all logarithmic. Each step up isn't adding, it's multiplying. And this brings us right back around to where we started. Remember that completely useless chart of the solar system? Well, check it out now. All we've done is change the vertical axis to a logarithmic scale. So instead of going 1, 2, 3, it goes 1, 10, 100, 1,000. Each step is 10 times the last. We're not plotting the actual volumes anymore, we're plotting the scale of the volumes. And suddenly, it all just clicks into place. The sun is still the king, obviously, but now we can actually compare Jupiter to Saturn and see how tiny Earth is. We've tamed the scale. At the end of the day, a logarithm isn't just a math problem. It's a completely different way of seeing the world. It's like a special lens that helps us finally grasp relationships that exist across these huge, almost incomprehensible scales. So I'll leave you with this thought to chew on. What in your world, from your personal finances to the